Hello, we are Roy and Yuval, and we are going to present our course final project, which is about Petanque game recognition. We will start with the game rules and our project goals, continued by image processing part, and finish with our results. Petanque rules are as follows. First, each player has 3 metal balls to throw. Second, the game goal is to be closer than your opponent to the cochonnet, which is a wooden color ball. Third, the player who is further away from the cochonnet is the one to play next. And last rule, the winner is the player who is closer to the cochonnet and his score is the number of balls that are closer. Our project main goal is to aid Petanque players with an application that will have the following features. First, detect all balls on the field and divide them into teams by their pattern. Second, compute each ball real-world position and draw an up-view mapping of the game. Third, detect the cochonnet and measure its distance from other balls. And fourth, provide a game status of who is winning and whose turn is it. Our image processing parts start with a background subtraction. We blur the original picture and use K-means algorithm to detect the field segment. Later on, we use frame burning method to subtract the noise beside the field segment. We use this method because most of the noise is commonly located on the field borders. In order to detect the game balls well, we first use median and Gaussian filters on the field segment, followed by Kenny's edge detection algorithm, and then our own implementation of half circles algorithm.
To differentiate between the patterns on the balls, we focused on each ball and masked the rest of the picture. We then used Kenny's algorithm once again on each ball to detect the edges in the balls. Since one of the teams has grooves on it, it has more edges, which becomes our differentiate factor. Following that, we tried to locate the cochonnet. It was necessary to look for the exact color representation and color spectrum in order to achieve good results. The color representation we chose is HSV. To calculate the 3D world location of each ball, we use the camera angle, height, focal length parameters from our filming device, additionally to the coordinates that we found before. We used basic trigonometry in order to find the formulas for the different axes. You can see here the formula for the y-axis. To summarize, the computation flow starts with background subtraction, followed by edge detection to find the balls in the image. Then we conclude their position in the world, and finally analyze the data to present it in a convenient guide. To conclude, our final results displayed here. The flowchart represents a real-life game with progress analysis by our application. Many thanks, hope you enjoyed. We were Yuval and Roy.